To LIS754 Systems Analysis and Design. This is the introductory session. Today we're going to have an overview of the course and think about systems analysis and design concepts. Your first assignment for this course is to create a short video to introduce yourself to both the class and to me. And what I would like you to do is to, at the end of this video, go to the Canvas site, go to the assignments that are on the assignments page, click on the first one that says Introductory Video, and follow the instructions. What I'm asking from you is your name, a little bit about your education, your past education, and where you are currently and what Dominican program you are. I feel very fortunate to have people from the Library and Information School, the Ed School, and the Business School in this course this semester. So I think it's going to be really exciting to have all these different ideas and different experiences coming together. So it'd help all of us to know what program you're in, the semesters or years, the length of time you've been in your program, and what your focus of studies is, the focus of your studies is, and your career goals, whatever personal experiences you've had, if you've worked in libraries, if you are a graphic designer for an ad agency, whatever your personal experiences are. And then just a little bit about yourself, what kind of intellectual pursuits, hobbies, free time activities that you engage in on a regular basis. And I look forward to hearing about this. I think it'll be, for me, it's going to be an interesting process. The course, this course is designed primarily to help you understand and to learn to use many of the tools that are part of systems analysis and design. The syllabus and schedule are on the Canvas site, and this course will heavily rely on Canvas. So you will spend a fair amount of time this semester in Canvas. On the first page of the Canvas site, the home page, there are links to a number of pages. One is for office hours. So my office hours this semester are on Tuesdays and Wednesdays from 4 to 5:30. If those times do not work for you, many of you I'm sure work full-time, please, if you have any questions, email me. We can arrange to meet in person at another time. We could use Skype. I'm very happy to Skype, which is often useful because then we can share screens, or we can talk on the phone. Any of those will work for me. I'm really glad to work with you to find a time that we can both, that would work for both of us. I expect you to follow the policies, the GSLIS policies for academic integrity and behavior. There's a link from the site to that. Please read that. There are a number of assignments in this for this semester, one every week. If you fall behind, it's going to be problematic for you. It will be hard to catch up. So please, try to make sure that you get all your assignments in. I understand that emergencies happen. I understand that illness happens, work problems. I understand all those things happen. If you if you know you are going to be late with an assignment, please let me know. It is, in this case, it is not easier to get forgiveness than permission. That is not a true statement in most academic organizations. So if you know you are going to be late, please let me know, because if assignments that are late lose points. The deliverables and assignments are on the Canvas page. The assignment page has every assignment that I'm expecting, the major assignments. There are discussions as well. They work together with the assignments. The primary deliverable for this course is a systems analysis and design specification. Everything that we do, all the assignments, all the lectures, all of the readings are aimed at helping you be able to do that. So if you do all of the assignments, if you take all the feedback that I give you for each of the assignments, you will have 2/3 or 3/4 of your final project done as an output of that. So it is really important to do these assignments every week. There's some help on the Canvas site for setting up Canvas for how you want to be notified of changes in discussions, of changes in or conversations and those types of things. So be sure to set those up in a way that facilitate your learning. I have a link there to some of the help documents. And here's the syllabus. This is what we're going to be doing this semester. There's two ways to view this. I'm only going to give the list view, but there's also this link to a schedule which puts it in a table. So you'll have the week, the time, the the title of the course, plus the readings. There's also a PDF of the syllabus. This is a requirement of the university that we have a printable version. If I change that, if I change the syllabus due to any reason, I will note it here that it's been revised. And you may note that this is a revision since if you looked at it the first day that the course was, the course was published. This course is completely asynchronous. That is, there will be videos, online discussions. We do not have a set meeting time. This is done to meet the busy schedules of people who are in graduate school. You can do this any time during the course of the week. I would ask you, though, to be sure to participate in the class discussions, participate in this before the last minute. You will not learn as much. You will not get good feedback. You will not be as successful in this course as you could be if you did it earlier in the week. If you wait till Sunday night, it's just not gonna work well. And if everybody does, then I'll rework the grading so that I can make sure that people are responding earlier in the week. Here's what we're going to talk about. Well, today we're just doing our introduction, getting to know each other, understanding what the course is, starting to think about these concepts. Next week, we're going to have an overview of systems analysis processes. What are the steps that have to be taken to do a systems analysis? They're called development methodologies, and we will spend quite a bit of time on that, talking about the different ways that systems can be developed. On week 3, we're going to talk about systems thinking, and this is a process by which we understand a problem set. It's a way of doing problem solving, and most of the work in systems analysis and design is problem solving. We're going to talk about project management. That is the process by which we actually can get our systems developed. And you will create a project plan. We'll learn about project management. You'll create a project plan. Week 5, we're going to get into significant details of requirements gathering. That is talking to the constituents. How do we do that? What is the process by which we can find out all the details that we need to know to create a system? We're going to talk about process modeling. How do we actually create the flow of data through a system? We're going to talk about object-oriented modeling In week 7, in week 8, we're going to design our data. Week 9, you're going to create the user interfaces for your system. You're going to create an outline of your specification of your final document in week 10. We'll talk about security, so how do we make sure that only the people who are supposed to get into our systems can get in. We'll talk about the system's architecture, how all the different components will fit together. And then we'll talk about how systems are actually built, the actual process once the design is completed of actual, and what the issues are in doing implementation. On week 14, you will create a presentation of your materials using some kind of a audio and video tool so that I can see a presentation from you on your systems analysis, on your systems design. And then your final project is due on May 3rd. Most systems are developed in teams. Most systems analysis is done in teams. And teams have a lot of, they bring a lot. Teamwork is very helpful in this kind of process. No one person, in my experience, has all the necessary skills to actually create an entire system. Or a big system. Certainly there are individual people who write systems, but it's usually more effective, it's usually faster, it's usually a stronger design when there are multiple people, again, bringing various skill sets together. Somebody might be really terrific at data design and not so good at interface design. Or someone might be a really great systems architect, but not really be a very good programmer. And so their code isn't as good as somebody else's code. In my experience and in all the reading that I've done, there's a number of ways that teams form for developing systems. Sometimes organizations will have a permanent, you will work in a permanent team. So there's a team leader, there's an architect, there's 3 programmers, there's an analyst, a set of people that work together all the time. Usually on a specific system that exists that's being modified and changed, or to develop a brand new system, either way. Sometimes there are temporary groups. We have a special project. We have a new state regulation, and so we have to change how our systems work. And so we're going to bring together a bunch of people to get this temporary project done. And sometimes they just form in an ad hoc way. So clearly it's temporary, but it's not as formal as a team for, say, changing a system to meet the state's a new state regulation. Teams work also in that you can have multiple people working on a task. So say programming or doing interface design, and the people divvy up that specific task. But mostly there are also, everybody has multiple tasks. So you might be designing the user interface plus working on writing part of the specification, doing data design, doing different tasks. So both of these are true, that you can have multiple people per tasks and multiple tasks per person. One of the primary functions of project teams is to be able to give feedback to team members on the work that they're doing and to review that work. And that's how we are going to be using teams in this class. So everyone is going to be doing their own individual project, but you are going to have a team to help you review and to provide feedback on your individual deliverables, on your individual assignments. And this is very frequently a way that teams in smaller organizations work. Oops, sorry. There we go. So for our course, we are going to use Teams to help us in our project, to help us to give a different perspective, to have a group of people to bounce ideas off of. So I like this. It's worked out very well in the past. Each person on the team learned a lot about how the other person's problem domain. Some people were better at one part of the had a better set of skills for one of the tasks than others, and so they were able to share, and it really worked out. It's really worked out very well, and I'm very optimistic that it will work out well for you as well. So for most assignments in the assignment, I want you to create an, so let's say this is for your first assignment, which is to come up with an idea for your project for the semester. So you will write an initial document. It will be the approximate word count, 500 to 1,000 words. It'll be well written, good sentence structure, spelling, grammar, those kinds of things. And when you write that initial document, you're going to share it with your team. And when you share it with your team, you're going to say, here's my document, and here are the things that I struggled with a little bit on this, or here are the things that I haven't quite resolved in this, and ask a couple of questions, such as, do you think the data is, the data that I have chosen is sufficient? That would be for the data design. So let's keep with the initial document. Does this seem to be sufficiently, is this system too big? Is this going to be too hard for me to do? Or I'm not quite sure who this would be aimed at. Who should I focus this system on? Should I focus on the front end? Should I focus on the back end? Any of those kinds of things. Ask questions. Your teammates will be following the list. They will give you feedback and saying, oh gosh, this seems really big. Maybe you should only do this portion of it. Or, gosh, have you thought about adding, it seems a little, maybe this isn't big enough. Maybe you should, think about adding these kinds of functions. When you get that feedback, think about it, evaluate the feedback, update your document as necessary, and then turn it on Canvas where I will grade it. I will participate in these groups. I will read the groups. I may not respond. I won't respond to every comment, but I will make sure that it's going well. I will be part of all of these groups. In order to get good feedback, you have to give good feedback. So you have to ask good questions, and you have to answer your teammates in a timely manner. You have to participate in this discussion throughout the week. If everybody waits till Sunday night, it's going to just be a mess. And I will reorganize the assignments to make sure that doesn't happen. But I expect, and it has in the past worked out, so I'm not anticipating that it won't, although there's a lot more people in this course this time. Okay, so that's teams. You're doing individual work, but you are getting review and feedback from teams. This is a very common process. So let's talk a little bit that we all have a common vocabulary for to begin with. Talking about what is a system. A system is, this is a pretty common definition, a collection of elements or components that are organized for a common purpose. And so we can think of that as, I have a system for, washing dishes, or cleaning the house or painting a room. We all have a little list of things that we do, a little way that we like to do things, or you have a system for organizing your, car repair parts or whatever. We all have little systems, little plans, a method that we do things with. But usually in current world, we think of systems as computerized systems, systems that are automated that make our lives easier. So PowerPoint is a system, Facebook is a system, MyDU is a system, Canvas is a system. All of those are sets of functions. They are elements and components. There's data, there's processes organized for a purpose, registering for a class, organizing the course content. In systems theory, this is the basis of systems theory. There is input that is processed and becomes output. The input is changed into output through a process. That data or functions or materials or whatever becomes changed. If there is no change, there is no purpose for the system. The output provides feedback into the input. This is basic, the most basic view of systems theory. We are going to spend most of our time thinking about these four things. What is input into the system? What are the processes that change that input? And what do we want to do to change the input into output? And how do we get feedback from the process, from the output, back into the system? This is the crux of everything and what we're going to be working on this semester. There are lots of types of systems. And this works, this drawing works for whether this is a system, a computerized system or a manual system. Whether it's how we organize our books on the shelf or how we sell life insurance. There are physical systems or abstract systems, so things that actually work on real things. There are computerized systems that will, manufacturing systems that will actually control the process of physically making things, or that just deal with abstract things like banking, right? So banking, so much of our financial system is digital, based on abstract money as opposed to the physical dollars, right? There are systems that are very open or systems that are closed. And so we think of an open system like something like Facebook, where the system itself is relatively small, right? You can put in a posting, you can put up photographs, but there's not a lot of processing to your data, right? Nobody's going through and, at least on the front end, looking at the particular data. There are closed systems, so something like the registrar system, where all that data gets input, all the class information. That's a closed system. You and I cannot go in and update information about the courses. I have to send an email to the registrar with the dean's approval to make any changes to that system. There is an open component. There's a user-facing component to that registrar system. You went into MyDU and you chose those courses, right? You put a little check in a checkbox for those systems, but you couldn't change anything. You could choose something, but you couldn't change anything. I can't do anything to that system except look at the data. And we all had to sign in to MyDU. We all had to have an @dom.edu or an equivalent kind of email so we could get into there, closed systems. We can have a formal information system, very much like the registrar system. Things can be much less formal, more a Facebook kind of thing where the data is very loose, right? So it's just straight, there's just text, there's nothing really, there's not a huge data model in Facebook. It's really very informal in how it comes together. Computer-based information systems, as we know, real-time systems. So those those are the manufacturing systems where their computers are actually interacting with material processes. So so we looked at that diagram a few slides before: input, process, output, feedback. And those are the primary elements: input, output, a process, a processor, something that's going to do a process. In addition to feedback, there's also something called control, so that I can have some, depending on the input, I can make choices about the output. So if I have, if somebody's supposed to put in their name as the input, and I am missing, say, the last name or the first name, my controls can say, I need more data. Stop the process, go back and get more data. If someone is supposed to put in a phone number and they don't, and they only put in 5 numbers, the system can say, whoa, I need I need that full phone number. Stop the process and go back. That's what is meant by control. So edits, ensuring that the data coming in or the data coming out is fine. There's certainly boundaries. We need to have edges to this system. We have to decide where the system is going to stop. So many of us find those frustrating things, like the registrar system, right? The registrar system doesn't really work with the financial aid system. And so things can get, those boundaries often seem really artificial to the end user. They're usually because of vendors, they're usually because of scope and technology and trying to do something that's doable, right? We have to put boundaries on things so that we know that we can accomplish a specific set of tasks, or to know where the system ends. But it also often is very frustrating to people. I'm sure you can come up with a number of experiences in your life where you've got to a point with the system and said, oh, I just need it to connect to this other system. This happens in businesses all the time. It happens in schools all the time. It happens all over the place because systems, they don't all work together, right? That's that boundary problem. And interface, we need to have a way of interfacing with the system. And we can have interfaces that are built for people, an end user interface, which we'll spend a fair amount of time talking about in this course. Or it can be a system-to-system interface. And that's what can be awfully frustrating to people, is when those system-to-system interfaces don't work the way that we would expect them to tie things together, like the registrar and financial aid. The registrar's office and the bursar's office, they may not talk together well. And then there's a technology and a social and a policy environment in which our systems live. In systems development, there is a very high rate of failure, somewhere in the neighborhood of 50 to 80%. So a good majority of systems development projects fail in some way. And they fail because either there's bad management or they're trying to solve the wrong problem. Trying to solve the wrong problem is much more common than you would expect. And we're actually going to spend a lot of time thinking about that in our systems thinking process. That's what we really want to talk about in that week. But in management, there's often a problem with organizational support. There's a project to update the system to meet the new state regulations. Nobody really wants to do it. There's not sufficient resources to be able to do that. Sometimes it's at the project level that the management fails. Somebody doesn't understand all of the components of the process, and a chunk gets missed. A component isn't updated the way that it should be, or there isn't enough time. We spent too much time on one section, on one piece, and now we don't have time to finish it the way we would really like to. Sometimes there are technical failures. The technical leadership did not work the way that it should. The system wasn't designed the way that it should be. Or that they don't have a methodology. It's just an ad hoc bunch of people, a bunch of people trying to, scurry around and do a bunch of stuff, but there's nobody really in charge, nobody really making sure that things are being done well. And we'll be talking about all of these as we go forward. So problem analysis, if we're solving the wrong problem, it's because we're not analyzing the problem well. We have to find the right solution to the right problem, and we fail often because we're solving the wrong problem, not because we did the wrong solution. I really love Dilbert, and so sometimes Dilbert really gets to the point of things, and sometimes this is what happens is that someone comes in with a solution, right? They have the solution. It's not to the right problem. And let's talk about a recent example. About every 5 or 8 years, a big systems analysis failure makes the news. And about 8 years ago, it was a problem with a system called PeopleSoft. A number of large universities paid between 2 or 3 universities, it was over $100 million to PeopleSoft to build a system for managing the finances and people and processes of universities. And it was a spectacular failure. It was many losses. It was awful. But a more recent example is healthcare.gov. And this is a problem. There were many points of failure in this. And I'd like to spend a couple of minutes talking about what went wrong with healthcare.gov. I think we see it, some people have seen it as a failure of government. Some people saw it as a failure of policy, but it was really a classic example of a system problem. So let's talk about this. So how does this work? What is healthcare.gov really? It's a portal. It's a way of connecting people to health insurance companies. That's what it was designed to do. I come in, I need insurance. I should be able to see a whole bunch of insurance policies that could meet my needs from a whole bunch of different companies. I pick one, and then the system will actually contact, I'll fill out all the paperwork, and the system will send my application off to that insurance company. That seems relatively straightforward, doesn't it? Unfortunately, it's not. The problem with this system was there were multiple problems with how the system was put together. Partly their fault, partly not. The thing is that insurance is really complicated. So every state has different insurance laws. So the first thing they have to do, and there's dozens and dozens of insurance companies, they all they all have different policies. So the system has to be able to know what state you're from, and sometimes there are county and smaller government regulations on top of the state requirements. So they have to know where you're from before you can even look at a policy. Then they have to deal with all the nuances of all those policies. Every single insurance company has their own way of collecting data, how they want names formatted, addresses formatted. All of the pieces of information is different, not only for every company, but often for the different types of policies. So if you get one kind of policy, you may need to, one company, you may need to have more information than for another one. So each of these policies needs to have their own enrollment form. Each policy goes to each company. Each company has different policies based on each governmental agency or entity in which it is being sold. So it's really complicated. So there's all these policy things. Then there's federal law issues. There's issues with, as you can see right here, timing things. So you have to enroll by 15th. This changes the nature of how people come to a system. So if everybody comes January 14th to sign up for their January 15th coverage, you can understand how that would affect a system. There's issues with tracking the policy. The government needs to, because of the regulations in the bill, needs to track the success rate and the ongoing, making sure that people keep their insurance policies up to date, so making sure they're not dropping out of there. So the government actually needs to track, or this website, healthcare.gov, actually has to track what kind of policies are being used, whether they're being renewed or not, whether they're being paid for. Now, they don't necessarily track that by individual, but as a group. So there's a lot of logging and tracking and information that has to go on. So it's a complicated, so it seems like it should be simple, connecting a person to an insurance company. There's a lot going on under the covers of this system because of the complicated nature of it. And then the system itself has some issues. First is there was a capacity problem. I don't know if you remember, but there were huge headlines, people waiting 2 hours to get a response from this. Well, in the first hour, they had 4 million people trying to log in. 4 million people. They did not expect that. It was a capacity issue. To have sufficient computers and sufficient capacity, computational capacity, would have, it would have sat, to handle that first day, would have just been astronomical in terms of cost, and they didn't anticipate it, right? So they misunderstood the interest in this. The second thing that they did not understand about capacity, and this is the political reality of this system, is they were only expecting to build this for a handful of states. They were not expecting that over 50% of the states were not going to be able to make either for technical reasons, financial reasons, or political reasons, were not going to make their own state portal. If all of the states had made their own portals, and this had just been for a couple of the smaller states, like Rhode Island, a little teeny state that doesn't really have a lot of resources, or Wyoming, or, some of those smaller states, then it would have been fine, because you wouldn't have had to have all of those policies, all of those locations, all of those forms, all of those things. But as more and more states opted out and said, we don't want to have anything to do with it, you take care of it, federal government, this is your dumb law, you take care of it, that changed everything, right? It was not designed for that to handle that capacity, to handle 25 states or 30 states. And some of those are very large states with very complicated insurance marketplaces. And so it just totally overwhelmed the system. It overwhelmed the system. And because they designed it for a handful of states, it did not have necessarily the capability of handling all of those design decisions that were made about handling this for 5 states didn't scale up well for dealing with 25 or 30 states. And then they had a problem with their process flow. So I don't know if you remember, but we're going to talk about process flow in a couple of weeks. And what they did initially is you had to sign up and make an account, not just tell them where you lived, but actually make a whole account. So Stacy Kowalczyk, 1234 Main Street, anywhere USA, blah, blah, blah. I had to tell them everything about me and make an account before I could actually see the health coverage plans. So they had to do so for anyone to even browse that first week. Man, that was a bad design decision. That was a bad process flow. Instead of just saying, what state are you in? We'll show you stuff. And then when you're ready to sign up, when you've decided, but they had this bottleneck of applications. I had to sign up, give you all this information before I could go anywhere else in the system. That was a process flow. That was the significant design problem with this system. The capacity, all those things, the designers, when they were setting this up, couldn't anticipate that, right? Who anticipated that so many states would not participate? But that single process flow decision, that caused a lot of problems. So you can see that it wasn't just as simple as not solving the right problem. They were mostly solving the right problem, but they had a problem, right? They made a choice that made it really hard for people to get to the system. They put some impediments up. Plus, there were all these other the environment for this was so charged. The environment was so difficult to deal with and very difficult to anticipate. So when they were, many levels of problems happen. But every once in a while, every few years, there's an example like this of a systems development failure that makes the news. So systems analysts are the people who are in charge of designing, modifying, or analyzing systems. The goal, of course, is to make effective systems that are useful to people, that work well. Systems analysts can work independently, but they usually are part of a technology unit, part of a team. They can work on new systems, completely new to the world systems. They can work on modifying existing systems. They can work on new components of existing systems, changing, finding problems in old systems that exist. Most systems analysts are not coders. They do not actually do the programming. They usually evaluate the code. They evaluate how the system functions. They know a great deal about all of those, the business rules for it. They understand how those business rules get implemented in the system, and they work on making sure that those actually work as designed. A systems analyst is often an interpreter between the business side of the house, and this is whether you're in an educational setting or an academic setting, a library setting, a business setting. They interpret the business processes of the organization to the technology people. And then they're often explaining the technology side of things to the business side of the house. So they often are the people in the middle that are explaining these different perspectives to the other set of people. This is a really, systems analysts make a very nice living. It's really an interesting career. Now, not everyone, in fact, very few of the people in this course, I think, will actually end up being systems analysts for their full-time job. But many jobs, many people during the course of their careers will either participate in a systems analysis function. They will participate in a systems development project. They will work with systems analysts. They may have a task on a systems analysis project. And I'll give you a couple of examples. I worked in a large academic library, and we were reworking the library's website. And so a number of people from the library were brought in to work on a project to advise the team on the functional requirements that were needed. And so we met with people who did the book cataloging. We met with people who did the reference people. We met with the people who were the financial people. We met with all sorts of people, the public services people, the interlibrary loan, all those different people had little teams. They talked about the things that worked well in the current website, things that were terrible, things that were missing. So they went through and systematically thought about what they needed. And, if you had told them 10 years ago that they would be doing that, they would have laughed. But they were involved in a systems development project. They had different tasks. We sent them off with tasks to, make lists of these things, make lists of things that don't work, make lists of elements that you want to have included in this system. I could name a dozen things like that in businesses as well as in libraries and in academic settings. So you very well may, in the course of your career, end up working on systems analysis tasks. Excuse me, that shouldn't have been in there. Next week, there will be readings on Canvas, videos, and I want you during the course of this week to think about your project for the semester. I want you to think about what kind of a system you want to develop as part of this course. Now, what sort of system you want to write the specifications for. We will not actually develop a system. It can be any type of system you would like it to be. It could be directly related to your work. If you work in a business, you might want to think about what system could really help your business. Or if you wanted to make a new application for a library, or you want to make a new application for your school. Any of those will work, could work out very well. You might want to write, so whatever you want to, sorry, just think about what would be interesting to you to think about for this entire semester. If you have questions about whether you think that this is an appropriate system, please email me. I am completely glad to talk with you about your idea. Or if you, just follow the assignment. So you will write up a document, you will share it with your team starting next week. That's next week's assignment. But I want you to start thinking about your project for your semester, for the semester. All right, talk to you soon.